This is the fourth lecture in the nervous system. In the body, we have general and special senses. The general senses are found all over the body and don't have a special sensory receptor. The general senses include tactile or touch sensation, pressure and vibration, pain, itch, thermal, and mechanoreception. General senses are able to undergo adaptation, where there is a decrease in sensation with prolonged stimulation. This is why we no longer notice things after a period of time, such as wearing jewelry or glasses. This helps to filter out the less important information. The visceral sensations report conditions within the body. Often we are not aware of these, in most cases, unless there is extreme pain or pressure. Our tactile sensation is touch. The Meissner's corpuscles are located in the dermal papillae. The Merkel's discs, or type 1 cutaneous mechanoreceptors, are located in the stratum basale of the epidermis. They are sometimes referred to as light touch. The type 2 cutaneous mechanoreceptors, or Ruffini corpuscles, are located in the deep dermis of the skin and also referred to as deep touch receptors. Pressure and vibration sensations are detected with the Pacinian corpuscles. Itch is detected with free nerve endings. The free nerve endings lack specialization and detect pain, thermal, itch, tickle, and some touch sensations. Thermal is the warm and cool sensation. Pain perception is also known as nociception. Nociceptors are free nerve endings for pain. Not all pain experience comes from where we expect. Referred pain is felt in an area overlying an organ distant from the source of the pain. For example, the heart refers pain to the jaw and arm, and those can be the signs of a heart attack. The diaphragm refers pain to the shoulders, the kidney to the low back and groin. Fast pain is the rapid, acute, sharp, prickling pain experienced immediately, such as when you stub your toe. Slow pain is a dull throb that gradually increases. After closing your finger in the car door, slow pain would be more like what you experience as the day goes on and you begin to feel it throb more and more. Another type of pain that is not typically mentioned in the notes, but most people have an interest in, is phantom pain, and that's pain in a body part you no longer have. This is seen commonly with amputees. When the body part goes away, the area of the brain that is dedicated to that body part is still there with neurons. Mechanoreception or proprioception is the joint position sense, or knowing where your body is in space relative to the rest of your body. For example, if you reach your hand above your head, you are aware your hand is above your head, even if your eyes are closed and you cannot see where your hand is. The special senses are those which require a special sensory organ. These include sight, sound, taste, smell, and equilibrium. Our sense of smell is also called olfaction. This information is carried through the olfactory bulbs into cranial nerve 1 and then extends back below the frontal lobes into the primary olfaction area in the medial temporal lobe. Our sense of smell is closely tied to emotions, memory, and excitement. Pheromones are a smell we do not consciously perceive, but attracts us to the opposite sex. When we smell different odors, they can have a unique chemical makeup that will trigger a unique set of ciliated receptors in the nasal mucosa, much like hitting keys on a keyboard. The more similar the smell, the more similarities in the keys hit on that keyboard or ciliated receptors. That information will be transferred up through the cribriform plate in the nose to the olfactory nerve, where it is taken to the olfaction area. The olfaction area is in close proximity to areas of the brain involved with emotions and memory, and that is the primary reason it is thought for the connection between these things. Our sense of smell as humans is actually pretty poor compared to other animals like dogs. You could think of a dog having all the keys on a keyboard, where we only have the black keys and are therefore not able to detect nearly as many smells. This is why we don't have bomb or drug sniffing humans at the airport. Our sense of taste is also referred to as gustation. We have 4 primary types of taste receptors on the tongue: sour, bitter, sweet, and salty. The taste buds are the receptors for that specific taste and tend to be in greater concentrations on certain parts of the tongue. Our sweet taste buds are in greatest concentration on the anterior tip of the tongue, while salty and sour on the lateral aspects of the tongue. Different sources show slightly different locations of the salty and sour receptors. Bitter is on the posterior one-third of the tongue. The posterior one-third of the tongue is also controlled by cranial nerve 9, which controls our gag reflex. Most poisons are bitter in flavor, and by connecting these areas makes us less likely to poison ourselves. Many medications are derived from the poisonous parts of plants and therefore have a bitter flavor. When you think of things like Tylenol or aspirin, they're very bitter to try and taste them. There is a recently discovered new taste sensation called umami, which is described as the savory flavor of things like meat, cheese, mushrooms, and things that are enhanced by MSG. Glutamate from MSG enhances the flavor of food by exciting the receptors on the tongue. This can potentially overexcite the neurons to the point of killing them and is thus sometimes referred to as an excitotoxin. While there may not be much serious concern with burning out a few taste buds, the concern is that this could potentially cross the blood-brain barrier and burn out neurons in the brain. There are also some studies out there suggesting one of the reasons that some people may overeat is feeling a lack of satisfaction in the taste sensation. In that case, it would mean more serious implications. If you burn out the taste buds, they're going to be eating more to try and achieve that state of satisfaction. The gustatory pathway works similar to the olfactory pathway in that each food stimulates a particular pattern of chemical receptors, thus giving it a unique flavor. The gustatory receptors transmit that unique pattern through an electrical signal to bring the sensation of taste. Because the mouth and the nose share a cavity, different odors can actually influence the taste of your food.